All right, so next up, we have Vincent, CTO and co-founder, Pylon City. Vincent is a serial entrepreneur and seasoned technologist with diverse knowledge ranging from cloud computing, IoT technologies, to energy management systems. Over to you, Vincent.
Thank you, Kang Yi. Today, I am honored to be able to share with everyone on the IoT landscape and its key trends in deployment. I'll begin with a rundown for 2020, followed by a technology overview, and we'll talk about the impact that it will have on major industries, and we'll end off with the key trends in deployment and some use cases. In 2020, we are in an unprecedented time in which we are in the midst of a COVID-19 pandemic. Yet by the end of this year, nearly 31 billion IoT devices will have been installed and connected. In fact, as I speak to you now, every second, 127 new IoT devices are being connected. Out of the 31 billion IoT devices installed, 3.5 billion of them are cellular IoT connections that are being established. Spending for IoT devices and technology has not stopped. In fact, there is a $1.29 trillion in global spending for IoT devices and technology alone, and 93% of enterprises worldwide in a survey have mentioned that they will adopt IoT technology. If we are to look into this IoT market itself, the market size for industrial IoT alone will be $124 billion by the end of next year. This is an attribute of widespread adoption of Industry 4.0. We see that there's at least 80% industrial manufacturing companies who have mentioned that they'll be willing to adopt IoT. The other key sector that we are looking out for today is actually in the healthcare IoT sector. The market size for healthcare IoT is projected to be $14 billion by 2024. And in transportation, we see that 90% of new cars are going to be connected through IoT. And with the electrification of vehicles just around the corner, we can see that there's going to be a lot more transport that will be connected to the IoT. IoT as a term is actually not a very old term, right? In fact, it was only in 2010 in which the term Internet of Things became official. IoT came about because it primarily exploits a bunch of standard protocols and networking technologies. Some of these networking technologies have been around for quite some time. And these are, in fact, the enablers that made IoT possible today. We start with some popular data exchange medium. RFID, for example, has been around for decades. And RFID was initially invented for tracking of assets. And later on, NFC was added. And NFC was actually invented to allow for device-to-device communication, but more for human-to-device forms of communication. And very popularly, you have seen a great uptick of NFC-based payment. Your Apple Pay, your Google Pay, Android Pay are all enabled through NFC. NFC too is actually used in marketing. You've probably seen NFC stickers appearing on your bus stop posters, where you could scan those stickers and then you can get content directly on your mobile device. And speaking of mobile device, another increasing diverse use of your mobile device is the fact that it has Bluetooth enabled in it. So we are beginning to see that a lot of devices today are connected to Bluetooth. Bluetooth itself is made up of two different profiles. You have Bluetooth Low Energy, which is popularly used in wearable devices like a Fitbit over here. And I think during the COVID crisis, we have seen the rise of the use of BLE beacons, which are used for tracking. And of course, in Singapore, we've been issuing out BLE beacons as well to the older folks in the population. Other than the use of BLE for tracking and for wearables, we also see Bluetooth being used in higher bandwidth applications, such as in your Chromecast, where you could then send media across from one device to another, projecting them on digital signages. The other thing is, of course, cellular technology has come a long way. We know that 5G is just around the corner, but yet without 5G, we actually seen a lot of devices, as I mentioned earlier on, that are already connected through cellular means. We have a mixture of narrowband IoT as well as LTE Cat-M. These are 4G technology, but these are great enablers to easily get devices connected right away through an existing network. For lower energy consumption devices, we have LoRaWAN, and we are beginning to see a greater update in LoRa because of the way in which we could easily gather data from low energy sensors used in urban farming, for example. We could also get energy readings as well as water readings from electricity and water meters, right, which are also powered by LoRaWAN. A slightly different technology is Sigfox, which also focuses on low energy consumption devices. However, Sigfox tends to be more popular in the European countries because it has a proprietary protocol on top of it. Other than LoRaWAN and Sigfox, there's also Zigbee. And in Zigbee, it was originally developed because of the medical applications, right? We have actually seen Zigbee being deployed in places like your clinics as well as your hospital. And it was originally made in such a way that we do not want conflict with existing Wi-Fi network. Z-Wave is also another upcoming exchange medium, and we are beginning to see it widely adopted in household. Right? This is in the space of home automation. So many home automation devices today are wireless connected to Z-Wave without having the need to clash with the existing Wi-Fi network. And speaking of Wi-Fi, we must not forget that Wi-Fi is still a very ubiquitous network. Every single building, be it a commercial building or a retail shopping mall, will definitely have a Wi-Fi network installed, which means that you could easily install IoT devices to tap upon existing Wi-Fi networks. The other thing is there's also Wi-Fi Direct, which allows for direct device-to-device connection, and this you've probably seen in printers as well as with mobile projectors, where you could directly connect your mobile phone to it and send information across. Lastly, we have TV white space, which is a reuse of the bandwidth that was previously used for analog TV. Other protocols that we have seen in terms of messages being sent, very popularly, we will send them through MQTT. And of course, we must not forget that a lot of APIs are connected today through RESTful HTTP, as well as through WebSockets for data streams. Some lesser known protocols will be like XMPP, which is used for your real-time messaging. It was originally used for chat, but we are beginning to see devices using it as well. And then there's gRPC, which is the Google version of remote procedural calls, where you could actually use a function to call a device. Some impact on major industries. 5 types of IoT applications we have seen in commercial IoT, as I mentioned earlier on, healthcare, transport, logistics, etc. Consumer IoT will involve things like your home automation, all right, and even toys today. Industrial IoT covers both smart factories as well as even smart agriculture. Infrastructure IoT we see today in building management systems and is part of the whole smart cities buzzword. And lastly, must not forget that there's also military IoT, where you have seen surveillance drones, combat wearables, and even exoskeletons being connected. To take a look at how impactful this has been on the industry, we find that the top impact right now is on manufacturing, which has the largest spending since 2016, followed by transportation and utilities. A recent study by McKinsey has also shown that the size of the economic impact of IoT is actually far exceeding other kinds of communication technology. So the key trends that we're seeing today in IoT deployment, right, we are beginning to see that people are beginning to be aware that devices need to be secured by design, right? And our own cybersecurity Singapore agency is coming up with a labeling scheme for that. We also have seen a combination of AI with IoT, especially with edge computing. So we're beginning to see like computer vision on the edge, as well as edge computing for robotic arms. This is basically a great enabler for a lot of different kind of applications, including autonomous vehicles and e-mobility. Say, for example, unmanned delivery vehicles, as well as your logistical drones. And finally, with more devices adapting to 5G, we are able to see that a lot more compute can be offloaded to the cloud, which can reduce the form factor for your AR and VR goggles. Some examples in key trends in deployment. In Pylon City, we have been in the space of utilities IoT for a while, and we have been using IoT to do solar energy monitoring. So our energy monitoring devices together with LoRa meters are able to be aggregated in terms of the consumption and generation data. And with this aggregation of data, we are also able to show the owner of the facility the energy consumed and generated on their facility in real time. Other ways in which IoT can be used, in industrial IoT, we've seen that the deployment of sensors along the production line and aggregating all these nodes of data is able to enable factories, owners to actually monitor the production line matrix better and improve their efficiency. So much so that they can decide whether they actually need to improve their factory floor or create another factory altogether. And finally, in the area of infrastructure IoT, we have a use case where we have deployed smart parking in Funan shopping mall. And for smart parking, right, we can actually use computer vision to detect car plates of incoming cars. And this unlocks other use cases, such as car park reservation. So if a person who has actually reserved a lot, have the lot that is actually taken up by someone else who hasn't reserved the lot, a violation can actually be detected by the system, and an alert can be sent to security guard to claim the car. To the building manager, they'll be able to monitor the car park utilization and the reservations on the dashboard in real time. All these different capabilities in deployment has enabled a lot of different use cases in IoT. And this, I believe, is just the beginning of a smart city. Thank you.